All right, so this Project Lead the Way PowerPoint presentation is on parametric modeling. Our goal here is to be able to get you guys so that you can do 1 through 9 of assignment 8.1. Between reading the directions, watching this PowerPoint presentation, and I'm going to make a YouTube video where I walk through those steps that you guys can follow. This should get you to the point to where you understand parametric modeling. That's what the purpose of 1 through 9 is. I want you to be comfortable with the process, understand what we're doing, and then be able to do the rest of the assignment on your own. Okay, so as we move forward here, what parametric modeling is normally when we do our dimensions, we put a dimension in, like 3 inches. And we're not going to do that in this case. What we're going to do instead is we're going to use algebraic formulas. So we're only going to define one variable in our model. And when you define one variable, then everything else is going to adjust to that one variable that's there. I'm going to try to give you an example as we go through. I do think the PowerPoint presentation is pretty good here. Parametric modeling, just works through the problems and does what it's supposed to do. So there are 3 ways that you could have parametric modeling happen. Even having geometric constraints, which you guys know these. That's an example of we're forcing restrictions onto our design. Parametric constraints is what we're learning today. This says assembly constraints presented later. I think we know these, like mate, flush. I believe that's what it's referring to. We'll find out as we move forward in the course. So here are some examples of geometric constraints: making 2 lines parallel, having a horizontal constraint or a vertical constraint, making 2 points concentric. All those are examples. Making 2 lines perpendicular are examples. These are the geometric constraints that we've already been using, and I'm going to use them in the YouTube video that I make. So here's an example of parametric constraints, where we're going to use a formula like this to define what the dimension of a side of an object is. And we're going to do that with the ParaCam. That's what number 1 through 9 is kind of addressing. It's going to be a spreadsheet format. It'll make sense once we go through and do it. Think about what we're doing when we do these. But here's an example of how we're going to have the equation set up. You're actually not going to type this part. You're not going to say D7 equals. You're just going to, in the box where you would put it, you'd put a formula like this. So this says you take whatever variable D2 is, multiply it by variable D0, and then you're going to divide that by variable D5, and then add 2 inches to it. So these are the symbols we're going to use for divide and add and subtract and multiply. Make sure you use the little star for multiply, otherwise the formulas won't work. You can't use X. Use the slash for divide, and so on. So when we're going to do it, we're going to actually do it with the ParaCam in numbers 1 through 9. Like I said, I'm going to make a YouTube video for that. But here's where you find it. This little box up here that says FX, that's where you can get into the parametric spreadsheet. You can also find that by clicking on Manage, and then when you click on Manage, you'll click on something called Parameters. And either way will get you to the same thing. You do not have access to 4.7, so we're going to recreate that cam from scratch, which is fine. It's not going to take us very long. It'll work out great. Here's an example of what I mean when I say we're going to use formulas. If you notice, they defined 2 variables. That's it. DO is 3 inches, and D1 is 1.5. Everything else is a formula that they put in here. And this is where we're going to do most of our work. This is exactly what the spreadsheet looks like when you go through and do it. So with the ParaCam, we really had 4 main dimensions. We had this hole down here. We had this radius. We had this radius. And then we had how far these 2 circles were from each other. That's really kind of it. So if you're making your formula and you just want to take one variable divided by 2, it'll put the UL behind it. That means that the 2 is unitless. It's not going to change your units in any way. So don't let that throw you off. When we go, if all of a sudden the UL shows up on the screen, it's totally fine, totally normal. And this is another example of what it's going to look like when it's done. It does say that the extrusion and taper angles are also typically done in the parametric spreadsheet. I'll show you those as well as we go through and do it. So it's nice to have a sketch like this so you really keep in mind like what you're trying to define. That's the thing that I found hardest about the assignment was I forgot which variables I named what, like when I was going to actually assign them. And just because I'm old and forgetful. So maybe making a quick sketch of what you're trying to do and have them labeled really works out well. Here's a example of what's in your assignment already. And this is what I mean by how we're going to have formulas to define things. Notice it's the same variables that are being defined over there. This picture is in your assignment, so you shouldn't have any problems with that. And here we go. So we're going to use this spreadsheet to go ahead and do the work. It's the same formula that we just had. So basically what this says is once you put a number in here, this number DO, this part, is half of D. Whatever D is, this radius is going to be half of D. And then this radius is going to be 1/4 of D. So you put some number here, like let's say you put the number 4 here. Well, half of 4 is 2. So it's automatically going to assign a radius of 2. And then 1/4 of 4 is 1. So it's automatically going to assign a radius of 1. So these formulas are going to define what these dimensions are. So you can make the nominal diameter anything you want. You just change one number and this entire cam is going to change its appearance. And that's really kind of the heart of it. And that's what this slide is showing you right here, where D is half of D is going to be what it calculates and puts into this box. 1/4 of D is what it calculates and puts into this box. And I believe they're even going to show you, like if you put a 1 here, well, half of 1 is half an inch. So then the maximum radius here would be half an inch. It does pay off to make comments over here about what these variables represent, although when you assign them, you can't see that. I wish you could. Maybe somebody smarter than me, an inventor, could figure out how to do that, but when you assign them, you can only see these things here, which is why it pays off to kind of make a list to be organized about it when you're going through and doing what you're supposed to do. But you can edit that just to have it say whatever you want. And they're just going to go through some practice stuff now. So at this point, I'm going to say that we are done with the PowerPoint presentation. Take a look at the 8.1 assignment and then look at my YouTube video for me working through numbers 1 through 9. The YouTube video can really help.